I think we can start now. So, welcome everyone to the live session of 2-week refresher course in computer science on next generation technologies, sponsored by Ministry of Education. We have our keynote speaker, Jonathan Bryce. Jonathan, who has spent his career building the cloud. He is executive director of the Open Infrastructure Foundation. Previously, he was founder of the Rackspace Cloud. He started his career working as a web developer for Rackspace, and during his tenure, he and co-worker Todd Murray had a vision to build a sophisticated web hosting environment where users and business alike could turn to design, develop, and deploy their ideal websites, all without being responsible for procuring the technology, installing it, or making sure it is built to be available, always available. This vision became the Rackspace Cloud. Since then, he has been major driver of Openstack, the open source cloud software initiative. On this note, I request Jonathan to take over, and I request the participants to post their questions in the YouTube chat box. We will take them in there. Thanks, Jonathan. Over to you.
Oh, well, thank you. Thanks for that introduction. It's great to have the opportunity to speak to you all. It's evening for me, and I'm in Austin, Texas, and for your morning. I understand that you've heard about some of the key infrastructure projects that are really important open source components of building modern infrastructure clouds and so things like Openstack and Kubernetes. And one of the things that I wanted to talk about this morning was another project that we are organizing within the Open Infrastructure Foundation, which is called Open Infra Labs. So I will share some slides here, and let me just pull those up. Okay, so Open Infra Labs is a project that we kicked off in collaboration with some universities and industry organizations, and the goal is really to connect open source projects like OpenStack and Kubernetes to the production environments where they are running, and you know, the individuals who are responsible for operating those. So to give you a little background, I just want to mention quickly about the Open Infrastructure Foundation and who we are and what we do. The Open Infrastructure Foundation is a nonprofit that was formed this year as the successor to the Openstack Foundation, and I mentioned, or it was mentioned earlier, that I helped to start the Openstack project and the Openstack Foundation a number of years ago, and what we saw over the last 8 or 9 years is that cloud infrastructure is really made up of not just any single project, but many projects that are working together and that are combined. So like OpenStack and Kubernetes and Ceph and ORAN and Magma and many open source projects that telecoms and banks and universities and manufacturers and all kinds of industries use to build out their digital infrastructure. And so what we wanted to do was take what we had started around OpenStack and expand that to incorporate more broadly all of the open source infrastructure that is really key to the world today. And so the Open Infrastructure Foundation is focused on kind of the next decade of infrastructure. What are we going to see as we see more adoption of artificial intelligence and machine learning, hardware acceleration, edge computing, all of these trends that are just starting, all of those are going to put more demands on the underlying infrastructure, the compute and the storage and the networking, in order to fulfill the needs of those cloud native applications and those AI applications. And so that's really what we think about when we talk about the next decade of infrastructure. We launched that this year, as I mentioned, and we had some great companies who joined in on that mission, including Facebook, Ant Group, Wind River, and Fiber Home. So companies from all over the world that have joined and are investing in this to help us build this decade. But ultimately, what is really the heart of all of this is a global community that exists in about 186 countries, and it's over 110,000 individual members who are part of this community and this mission, and they're contributing to projects. They're running these projects. They're educating others about them, and that's what is what's so special about open source and open communities is the ability to make this available to everyone. And so when we think about what we want to see happen as a community and as an organization, we think in terms of the problems that we want to solve and the way that we want to solve them. And so the problems that we are looking at, they are those key technologies that we think are going to be important over the next decade, and the infrastructure that enables them. So again, containers and cloud native, AI and machine learning, continuous integration and continuous delivery for software development, edge computing, telecom clouds, hybrid cloud, all of these kinds of things. This is what's going to really drive our industry forward. And those are the problems we want to solve. And the way we want to do it is we want to make sure that we do it in the open, so that as these really key technologies develop, they're not locked up inside of any particular company or country or community, but they are available for everyone. We want to collaborate across all of those kinds of boundaries so that everyone can have access to these key digital technologies. And the thing that's great about it is, what we've seen in open source over the last 20 years is that when you collaborate around fundamental pieces of technology, you actually unlock tons of commercial opportunity as well. And if you look at these open source components that make up these different areas, there are tens of billions of dollars of global revenue that gets spent on these open source components already today, and that's only going to grow. So, I feel very fortunate that I get to work in an area where we are taking technology, we are making it open and available to people all over the world and all kinds of use cases. And at the same time, we're creating commercial opportunity for companies, which means that there are jobs and there are businesses and there's money that's able to fund this and hire developers to write the software and kind of bring it all together in that way. So that's sort of at a high level what we work on and what we think about. And as we do that, we have a number of companies that help us. I mentioned some of these platinum members that joined as we were launching the Open Infrastructure Foundation this year. We also have a number of gold members, and you'll notice that there's representation from many countries around the world, across Asia and Europe and North America. We want to keep expanding this as we go and bring more companies into the foundation and have more people helping us with that mission as we go along. So I said that I wanted to specifically today talk about Open Infra Labs, and Open Infra Labs is a newer project that we kicked off last year. And the way that we think about the goal of Open Infra Labs is to connect the kind of upstream open source project development that happens with the production usage of those projects. One of the greatest things about open source is how much of it there is. Anything that you want to do, you can pretty much go out and find an open source project that does that. But it's also a big downside that there's so much open source, because how do you know which open source is ready for production? How do you know which open source is developed in a mature and reliable way? Software supply chain security is a big concern these days. And so what we wanted to do was get together a group of people who are running open source software in production today and allow them to share what they are learning with the upstream communities who write the software and with the world at large, so that we can have a better connection, so that upstream software doesn't just get written in a vacuum that's completely disconnected from the scenarios and the environments where it's running. And so this project was kicked off by a collaboration of universities in the Northeast United States. They're listed out here: Boston University, Harvard University, MIT, Northeastern, and UMass. And these are, these are all very strong universities in the U.S. with a lot of talent and a lot of research that goes on there. And what they have done is they've built clouds for their university communities and for the kind of broader research and academic communities that surround those universities. So this is a really cool way that we're able to get real world usage and then share it back. And if we look at what we see as kind of the key drivers for why we need something like this, we see that, again, demand for cloud and demand for infrastructure is exploding. There was a recent IHS market survey that said that people are expecting to double the amount of physical servers in their data centers through this year, which is really, kind of a hard stat to comprehend that people are planning to double their capacity. And I talked already about some of these new workloads and the proliferation of open source. And you put all of that together, and what it means is that we need better automation. We need more scalable systems for managing our infrastructure, and we need tighter integration between the infrastructure components, the application components, and the software itself. So that is kind of why we think this is really important. A lot of times when you see open source projects, one of the things that I think can be a challenge for people adopting it is that open source communities often work fairly independently of each other. And it's almost like having separate product teams within a single company that don't talk to each other. and they have their own roadmaps and their own release cycles and their own patterns for how they develop and test. And the way that Openstack does that is slightly different than how Kubernetes does it, and that's slightly different than Ceph. So having a way that we are able to look at this holistically is really, really important. And I'll give you a couple of examples with data of why that is. If we look at our user survey data that we collect at the foundation about OpenStack deployments, 70% of those OpenStack deployments are running Kubernetes. And it's a similar number for how many are running Ceph. So, to me, that says that these are projects that really complement each other, and people are wanting these different capabilities from these different projects. But are we doing enough to make sure that they work really well together? And I think that historically in open source, that kind of integration burden has often fallen to the Linux distributions, the Red Hats of the world, the Canonicals and CentOS and SUSE and all of those. That would be where these packages from upstream communities would get integrated and tested. So if you think about the thing that really drove the explosion of websites, the LAMP stack, that was Linux, Apache, MySQL, and PHP. And how did most people get their LAMP stack? Well, it was what came on their Linux distribution. And Red Hat or Ubuntu or Canonical or Debian or whatever community was putting together that distribution was responsible for picking a version of the kernel and a version of MySQL and a version of PHP and a version of Apache that all work together and giving you updates and patches. But we can't do that at just the distro level anymore, because there's been such a proliferation of open source. And there's also just so much more infrastructure today than there was 10 years ago. So, we have just a much broader variety of how this software gets deployed, where it's running, what it's being used for. And so I think we really have to be more aware of that at the development time and more aware of that in our upstream communities. And that's kind of one of the big reasons for this project. I've talked a little bit about this already, but just, in terms of a definition, I keep saying open infrastructure. And what is that? Well, that's infrastructure that's built with open source components. And when I'm talking about infrastructure, I'm often talking about the lowest layers of a stack. So that is the compute, the storage, the networking. That might be virtualization, it might be bare metal, it might be layer 2, layer 3 networking. It's the really fundamental components, the building blocks that then get composed into an automated set of infrastructure with Kubernetes running on it, or a different kind of application. In the academic context, one of the biggest use cases that these universities are using is for Jupyter Labs. They're running lots and lots of instances of that for their classes and for their researchers. And so, that is what the end user wants. But in order to deliver that, there's got to be servers somewhere, there's got to be networking, there's got to be storage. And so that's the infrastructure level. And these are all very, again, like I've been saying, very tightly related to each other and dependent upon each other. So we need to think about it more holistically. I won't stay on this slide long. It's kind of just continuing to make the point that I've been talking about here. And so for Open Infra Labs, what we see is this is really that kind of last mile for open source software, where it all comes together and the different components are integrated. And often when you do that as a user, you'll discover that there may be something that isn't totally there. There may be a gap for logging or for security, and you kind of have to take on some of the responsibility to fill those gaps and to apply something in there that kind of meets the full need of the application of the use case. But often that solution that you came up with stays internal to your organization. And I do it one way, you do it another way, and your neighbor does it a different way. And now out there we have 3 different versions. We can't share, we're not benefiting from each other's work. And that's not a great solution. So this is one of the key things within Open Infra Labs is it's both a community of practice who's focused on integrating these components and sharing their methods for it. But there's also code repositories where things like telemetry scripts, the way that we can get information and observability out of these clouds is shared, as well as other configuration components. This is where the university aspect of this is very important. I've worked with lots and lots of very large organizations all over the world who are running these software components, but they aren't really able to share some of those details of how they are making it work. They can up to a limit, but there's a limit still. And one of the great things about working with these universities is, as part of their mission to increase knowledge, they are more willing to be very open about how they are running these environments and sharing their configurations and their data and the kind of experience that they're getting from the clouds. So this is where this partnership between industry organizations like Intel and Huawei and others, along with universities, becomes very valuable for our community overall to share that operations knowledge. So I mentioned that this started with a collaboration from these universities in the Northeast. They had started something called the Massachusetts Open Cloud, or the Mass Open Cloud. This is a fully open source cloud. It has thousands of users, and it's shared between all of these universities. There's also several other clouds that have spawned from this environment. Something called the Northeast Research Cloud, the Open Cloud Testbed, which is part of a National Science Foundation project within the U.S., and several other kind of related efforts around, some of them around storage and some of them around networking within the university space. It's made up of hundreds of servers. That's actually been growing. I think that it will be over 1,000 servers fairly soon. And one of the things that's so great about it is, because again, the data around this is public. One of the things that they are able to talk about is what they're running, how they're running it, and also the fact that it it is up to 10 times cheaper than running on the major hyperscale public clouds. And that is shocking to people sometimes, that you can run your own cloud for 10% of what you would pay Amazon. That's not the common narrative out there. People think, okay, well, Amazon is always going to be able to do it cheaper, but that's not the case for a lot of use cases. I think, and to be clear, we have a lot of public clouds that are based on OpenStack, and I think public cloud is very powerful. I started one of the first public clouds in the Rackspace cloud, but I think that we have to acknowledge that the point of public cloud is elasticity. It's instant access to infrastructure and the ability to turn it off instantly as well. And you pay a premium for that flexibility. That's something that you can leverage when you don't know how much infrastructure or workload is going to require if you're just launching something, if you are going to have a traffic spike. Public cloud is a great thing to leverage. But if what you have is an application that is fairly well defined and fairly steady state, then paying for that flexibility and for that kind of instant provisioning is really not a cost-effective way to get that infrastructure. And so in a case where here, they have a decent understanding of what their workloads are, what their applications that they're running are, they can do it for a dramatically lower cost than public cloud. So this is actually where Open Infra Labs started, which is great because it means that from the beginning we've had real world use cases, real world users, servers in a data center with production workloads, and that is a key piece of the mission for this overall. This is a picture of the data center where that cloud is deployed. It's also on a high-speed network link that joins a number of universities in the Northeast of the US. So it's great because it gives them the ability to actually share this capacity even beyond the kind of 5 core universities, and lets them collaborate more broadly around it. So this is kind of the Pacific Research Platform is an environment that's in California on the west coast of the United States, and it involves a large number of universities that are all running elements of infrastructure and sharing it broadly together. The capacity of this data center in Massachusetts is actually in aggregate the same as all of these the Pacific Research Platform together. So it's a pretty big collaboration that's coming together and actually providing a lot of infrastructure to the academic community. So just kind of wrapping up here, what do we want to do with it now? Our mission is to make it easier to consume and operate open source infrastructure projects and software projects in general. We want to leverage that foundation of this real world environment that comes from these universities in the Northeast. We've already created spaces for people to collaborate and have started to see that happening over the last year, with especially around certain things related to logging and telemetry. That's been a big area of effort. And now what we are wanting to do over the next year is to expand this beyond the kind of first Open Infra Labs region in the Northeast and have additional regions that we open up with other partners and universities, and really turn this into a global effort so that we can engage our entire community, bring more people in, and again, ultimately get to that place where more of us can run and operate these open source infrastructure projects. So that was it for the slides I had. Hopefully that provides a decent overview of the Open Infra Labs component and the Open Infra Foundation. I'd love to answer any questions that anyone might have.
So thank you for providing the background to the Open Infra. We have been waiting so long. And one thing I looked at the top, we had 4 principles of O. Now there is an open philosophy. Although question may or may not be related, but that sounds very interesting to us because it gives the possibility that maybe we can have an open infra in India in set of labs and collaborate with you. That could be a possibility. So maybe you can throw some light on that open philosophy aspects of it, which is at the high level. Yeah, sure.
Sure. Yeah. So there are there are many elements to the philosophy of open that we have. So I have to pick which ones to talk about. But on Open Infra Labs, the intention is definitely to expand this to other areas of the world. And I think that it would make a lot of sense to figure out. Again, this is something that doesn't have to happen right away. We're looking to do this over the next year or 18 months. So it's something that we can start talking about and figure out what a path forward is. But I think that especially given India's strong academic community, and especially around technology, that it would be a great location to try to build towards having another Open Infra Labs region there. The things that we are always thinking about within our community, you mentioned, the four opens is a key philosophy for our communities within our foundation, and those are open source, open development, open design, and open community. And what that means is that at every stage of the technology process, we believe that it should be open and collaborative and available for everyone to participate. Open source is really about a license. What kind of license is the software available under? Is it something that I can reproduce it, modify it, distribute it? Those are kind of the keys of an open source license. But we think that what's much more powerful is when you then say, well, as we build this software, all of the code that we write along the way is going to be available in the open, and that's open development. So think, project on GitHub that's collaboratively developed iteratively. Every code change is available for review, and everybody gets to see it as you go. Because that's not the way that all open source has been done historically. Sometimes organizations will write a piece of software, release it under an open source license, but not give you a chance to see how they got from the beginning to the finished product. And we think that it's much more powerful when people can participate along the way. Open design takes that even further, which is, not only is the code up for review, but even the ideas should be openly debated and reviewed before they're implemented, so that we are all getting, the best ideas at the end of the day are what then turn into code and end up in the software. An open community, which I think is really, where the Open Infra Labs project plays in. Open community is about allowing people to participate in all kinds of ways, not just by writing software, but also by running the software, by sharing knowledge about how to operate it and how to take it into the real world. And also, making sure that we are doing it in a way where it's available to people everywhere, whatever they may be doing. So yeah, those four opens are very key to how we work, and Open Infra Labs is definitely something that plays into that.
Yeah, just to add on to that, of course, you always wanted upstream first, we started with, and then now you moved to operation first. So are we going to move to automation first as the next step? Is that likely? Do you see that as another vision of Open Infra?
Yeah, I mean, I think that operate first is an effort that started within Red Hat when they noticed some similar things where just there were too many open source projects that were too hard to operate and to run after the software was written, and so when we started working on the Open Infra Labs project, they sort of have brought operate first into that group within the overall banner of Open Infra Labs. So operate first is almost, another philosophy about how to write software and how to manage open source communities. Open Infra Labs is kind of one of the implementations of it. It's a home where we are operating first, where we are taking software straight from upstream and running it and sharing all of that information back. And I think that ultimately, you know, all of this, the reason that we need all of this software is, like you said, automation. When we see just the sheer number of servers and devices that are out there, I saw a stat recently that someone estimated that we have 50 billion devices that are connected to the network now. 50 billion. It's crazy to think about, but that is the scale of what our just technology fabric has grown to now. And so, of course, when I started in data centers, we called them crash carts, because it was this little cart, had a keyboard on it and a monitor, and you'd run up and down the data center aisles, and you'd plug the keyboard and the monitor into a server, and you'd sit there and you'd manually, you know, log in to the console. And it was a crash cart because you generally did that when the server had crashed and it needed manual intervention. You know, that worked when we had a data center with hundreds and even a few thousand servers, because they weren't all crashing at once. But, you know, eventually we had hundreds of thousands of servers. And at that point, you must have automation, or you just cannot manage the systems anymore. And I think that at just the rate that everything has been growing, automation is absolutely at the heart of all of this open infrastructure movement, and it is absolutely 100% necessary for what we need for the next decade.
Vipin, go ahead.
Yeah, thanks, Jonathan, for such a good introduction of Open Infra Labs. And I have some questions like, do we have like some mechanisms to join this Open Infra Labs, or is it a proposal kind of things, or CFP, like how universities can join this initiative of Open Infra Labs?
Sure. So the community is collaborating at openinfralabs.org right now. So openinfralabs.org is the website for that. If there are universities that want to get involved, kind of at a bigger level, then I would say, you know, reach out to me, and that's going to be the best way to get engaged and figure out, you know, how to have a more formal engagement in the program. You know, the existing universities all have fairly deep engagements with, again, data centers and people and staff who are running these environments and lots of users. So, you know, if we want, and it took us months to set that up and figure out how to organize all of that and also help them start to work in the open. So, you know, if there are universities that are interested in participating at that level, I would love to talk to anyone who wants to do that. And, you know, you can share my email address. It's jonathan@openinfra.dev. But yeah, that is that. I think that for individuals who are interested in kind of seeing the output and participating, there are meetings that happen pretty regularly. I think we've published some of the recordings from those meetings, and there's some source code, and all of that can be found at openinfralabs.org.
Also, we get one question like, is that Open Cloud Testbed OCT are part of this Open Infra Labs only, or is it just like separate things? Or and how, if let's suppose if there's an initiative from, let's say, some universities, and then like what is the process like? For example, how you as Open Infra Labs help them, like for example, in KT, or like in transferring knowledge, or like how you can help, or how we can, what is the process of it?
Yeah. So the Open Cloud Testbed is an environment that's, you know, Open Infra Labs is really the collaboration space. So it's where people are coming together to, where we're helping to organize the meetings and the code and the documentation and these kinds of things that the community is creating. Downstream from that, you have these actual cloud environments like the Mass Open Cloud and the Northeast Research Cloud and the Open Cloud Testbed. Those are environments that are leveraging the output of the Open Infra Labs community. So, the software blueprints, the reference architectures, the scripts, the telemetry, that kind of thing. So in terms of where the help comes in, what we do is we have a heavy focus on organizing the experts and getting them to be able to share their information, and then we also try to help the operators find their way to the other operators that they can collaborate with. So if there was a university that was running an OpenStack environment, or an environment with OpenStack and Kubernetes, then we would help them get plugged into the broader community. They could share their use cases and their requirements and their challenges, and work within our kind of overall space to collaborate with other people who are doing the same things.
Yeah, so we have one question, and this is really, really interesting as well. Sometimes it really impressed me as well. Like, what is the relationship between open infra projects like Airship, Starling X, etc., with Open Infra Lab? So I want to extend this question. Like, see, we had in previous talks, we had Arpit or Priyanka as well, talking about like there are a lot of open source projects, right? From CNCF, from LFN, and now OpenStack, and some are like overlapping as well. Like maybe Magma, maybe Airship is using, like in CNTT, Anuket, we see Airship as well. So means if someone wants to understand like how this whole ecosystem works, or if you can tell us more like how beginners can start with to how to understand like where to go, where to not, like can you help us in this?
Yeah, well, I think that the key concept to understand within open source is the concept of kind of upstream and downstream. And upstream and downstream do not exist as only two things. There's not one upstream and one downstream. It means that somewhere something is getting produced, and then somewhere later it's getting used. And so if you think about like Linux, for instance, at the very highest level, you have the Linux kernel, and the Linux kernel is upstream of a Linux distribution, and a Linux distribution might be upstream of a product like Red Hat Enterprise Linux, or a canonical LTS version of a distribution. So the concept is really key to understand that at some point there's some software that's produced, and then as you go down, it often gets used in multiple different ways. So if you look at something like Starling X and Airship and some of the LFN projects, a lot of those are downstream of OpenStack. They all contain OpenStack components within them, but they are maybe solving slightly different use cases. So they package those components somewhat differently, and they include other additional components, again, like a distribution. Airship, for instance, has been built for repeatability. So Airship has at its core this concept of being declarative, like Kubernetes, where you can describe the state that you want it to provision and maintain, and then it's kind of hands off after that. And it will fix errors, it will spawn new nodes if a node fails, and it does all of that without your intervention. And the reason it's designed like that is because AT&T used it to do their 5G rollout, and it had hundreds of locations that they needed to deploy it in. So, again, kind of back to my crash cart war story, you can't manually deploy hundreds and hundreds of locations and know that they're going to work, and then also run them in a manual way over the years. So, Airship focuses on repeatability. Starling X is almost like an embedded form of these components of OpenStack and Kubernetes, in the sense that It runs specific versions of them. It's extremely tightly integrated, and it's intended to have kind of one way that it does it, so that you can deploy it into factories and into industrial use cases where you again may not have like you may install it in a place where there is not a sysadmin. It might go into a factory where there is no kind of highly technical person available to go debug that system. So that's really the key concept. Is upstream you have things like OpenStack and Kubernetes and Ceph, and then downstream sometimes those end up into a Red Hat Linux distribution or a canonical Ubuntu, or they might end up in kind of these community distributions like Airship, Starling X, Akrano, those kinds of things.
Thanks, Jonathan. And in one of the slides, you showed like about cloud native as well. So what do you think, like, what is the scope of this cloud native OpenStack kind of things? And if some, like, for example, in universities, I know like people are working on like OpenStack, cloud native OpenStack, one of the projects, Openstack. So how they can also like give inputs or collaborate and give some, get some problem statement from OpenStack community, so that cloud native OpenStack can be like a reality? Or what do you think? What is it necessary, or what do you think as a future of this cloud native of OpenStack?
Yeah, I think that the way that I kind of think about that the cloud native OpenStack is OpenStack itself is a set of microservices. There's a microservice that provisions virtual machines, a microservice that provisions bare metal, a microservice that provisions block storage devices. And the point of the whole kind of cloud native concept and philosophy is to run microservices in a more automated and resilient way. So in that sense, I think that it makes a lot of sense to look at cloud native concepts like packaged in a container, immutably, with as little state as possible. Like those kinds of concepts, those just result in more reliable application operations. And so if you take those concepts and you apply that to the Nova scheduler and the Nova API or the Sender API, then you can definitely benefit and see benefits to how you manage your OpenStack environment, how you do upgrades, how resilient they are to failure. And so I think that the concepts are really very valuable. What I would say I have seen is that over the last few years, almost every OpenStack distribution that I know of has moved towards some form of kind of cloud native packaging of the OpenStack services. Almost all of them are using some form of some of those concepts in there. Airship is one that did it very early on, where they actually were running all of the OpenStack services as kind of a very lightweight Kubernetes environment. And they did an awesome demo at our summit in 2017, I think it was, in Sydney, where they did a live upgrade and rollback with network traffic flowing through basically an AT&T environment, and there was zero downtime because they were managing those OpenStack services through containerization. So yeah, I think that's the concept there. Now, I think what gets confusing sometimes about it is, on the flip side, if you are offering Kubernetes to application developers to write arbitrary applications inside of an enterprise, you probably don't want them to just be running Kubernetes directly on servers, because then you're going to have a lot of overhead and management burdens. Kubernetes wants to run on automated infrastructure. It wants to run on a cloud, again, cloud native. So, a lot of people understand that in the sense of running it on something like AWS or Google, or Azure or whatever. But what we see is a lot of times in large private environments, people will use orchestration, container orchestration, in a very lightweight way to manage OpenStack services. And then they will use that OpenStack footprint to manage the rest of their data center. So there may be 5 servers that are kind of the OpenStack control plane, and then 500 or 5,000 or 50,000 servers that make up the rest of their fleet. And within that fleet, some of it might be provisioned as hypervisors for virtual machines. Some of it may be bare metal that they are pushing hardware intensive workloads like data analysis or data storage to. And some of it may be where they're running Kubernetes to orchestrate containers directly onto bare metal or in virtual machines. So it gets confusing because you can actually make use of these at multiple layers, and rather than thinking about them as really distinct and separate and like they never touch, I think about them as these kind of interlaced tools that actually have a lot of utility at different points of the stack.
Yeah, that's really interesting. And also one question we're getting from if you can tell us how this Open Infra Labs or OpenStack, so if you can tell us some initiatives about hybrid cloud as well, like do you have some project on it? Or because in universities, sometimes it happens that we cannot scale our infra like industry can do or someone else can do. So if we can host some applications on-prem, some research projects on-prem, and if we can transfer some workloads on public cloud. So is there any initiative around it? So if you can tell us more.
So yeah, 2 things. One that is not that doesn't exist yet, but I hope will exist soon, is we have been talking with a couple of companies about kind of some multi-cloud management tooling. I think that that's going to be something where there's a need for that. I mentioned earlier that OpenStack has public clouds. It has I think that there are something like 85 public cloud data centers that are running OpenStack around the world. And so it has a pretty large footprint already of public cloud providers. So as I said earlier, like OpenStack is definitely not just for private clouds. And so we want to make sure that there are tools for kind of doing hybrid work, even within the OpenStack world, but also spanning to other providers. But the other thing that I would say is that hybrid is still very difficult, mostly because of things that are outside of the cloud. It's what makes hybrid cloud hard is not OpenStack or AWS or those kinds of things. What makes hybrid cloud hard is data. Where does the data live? Who is the authority for my database records? Who's the authority for this set of files that I'm supposed to be tracking? And so a lot of times what it comes down to for successfully creating a hybrid cloud application is it comes down to the application design itself. Within the OpenStack development community, we actually run a very large hybrid cloud application, which is our software development, code review, and testing system. It actually runs across, I think, something like 13 different zones across 6 cloud providers or something like that. That might be what it's run at the max, but it does thousands of tests a day, and it's a very distributed application that makes use of many different clouds, and because of that, it's resilient to cloud failure. We're able to shift load around. It's also not something that runs in any single jurisdiction, which is great for a global community. So, but what makes that work is that application itself has a concept of basically, kind of cloud balancing and sending workloads to different clouds. There's not really a generic tool yet that does that, and I think that having something that where you can just kind of take an application and say make it hybrid, that we're still years away from that being reality, just because, again, of data and networks and kind of some of those fundamental pieces that don't work well when they are split across really distant pieces of infrastructure.
Yeah, thank you for that. I would frame a question rather. See, we are seeing that there is a lot of movement in the worlds of GPU and the GPUs. And in OpenStack, we have got Ionic and Cyborg. I did not see much of that in the open infrastructure projects yet. What I want to know is, since there is a new term called DPU, which has come up, emerged, called data processing unit. So we talk about CPU, we talk about GPUs and the GPUs with the multi-core and what is called CUDA, that is CPU unified architecture and all that, with open API from Intel. And so we have Intel and uh, NVIDIA competing in that space, plus the new semiconductor chips are coming up from many a place, okay, to name few. So let's take the subject in the terms of software, because to get the automation, to get the acceleration, to get offloading, which are the key features in the networking, whether you talk of NVLink or you talk what do you call the bypassing the CPU and just direct DMA, direct memory access between the GPUs and the RDMAs and the putting of them in the memory bus in the terms of NVMe. So what do you see? Where does open infrastructure pick this up? Whether it will come from open infrastructure or OpenStack, or how do you see that panning up, and how you visualize in long term where we will use this? And because even to put simple, Cyborg and Ionic we have seen the challenges there, especially at the
Yeah,
internet.
I think that you're getting to the heart of why infrastructure is so important. The infrastructure is kind of the plumbing of the tech world. People in general don't want to think about it; they just want it to be there and they want it to work. And that's what what we try to deliver through cloud technology is those core infrastructure components in a way that just works. But as I was saying earlier, when you look at things like AI and machine learning, that is an algorithmic technique that gets implemented in software, but gets optimized in hardware. And that hardware does not look like the compute of 10 years ago. That hardware looks like, like you said, GPUs and hardware accelerators that are dramatically different in what needs to get provisioned. And so I think that's a great example of where what we need to do is build out projects like Cyborg. Cyborg is an OpenStack project that is kind of an inventory and provisioning management system for hardware accelerators, GPUs, FPGAs, that kind of thing. It can field program the FPGAs, and it can program a fleet of them all at once. These are still new things, though. So I think that you're right, that they don't work. They don't work with the level of sophistication that provisioning a CPU and some traditional memory and a block device do, because those are concepts that are decades old. And so when we look out and we say, okay, well, what are we going to do for another decade of infrastructure? I think that there's so much to do because we need to be able to take these really still quite new concepts of algorithm, application, and hardware, and make them work better together. I'll give you one concrete example of what one OpenStack user has done, though, and I would say that they're they have a team that's pretty strong technically. So our hope is that we can get this into a more mature state where everybody can do this kind of thing. But they have a pretty large data science practice within their organization, and what they have done is taken the sort of use and provisioning of GPUs from being something that's just handled within their data science team and actually put that within their data centers and their infrastructure team so that they have a fleet of GPUs out there. And on top of that, they have used OpenStack at the infrastructure level, as well as Kubernetes and TensorFlow and some other scheduling software to allow those data scientists to be able to feed jobs into that system and run it on a range of hardware that has a different set of capabilities, a different set of performance characteristics, and also kind of a priority. So if you have some analysis that you want to do and you would like to have it run on a GPU, but it's not super important, then you can say that priority and it'll sit there in a queue, and at night, it'll run across as many GPUs as are available, and you'll come back and you'll have your results. If you're doing something that's more of a real-time analysis, like image recognition for fraud detection or for CAPTCHA kind of stuff, those need to be handled much more urgently, and so those preempt workloads and get direct access to the GPUs. So that's the kind of thing that like I said, it's one of the more sophisticated real-world use cases that I've seen with hardware accelerators, turning them into a fleet, a cloud of GPUs with these different characteristics. And I think that turning that into something that's more generally useful and available, that will take years of work to get right and to make available to everyone. And that's just one single use case of a cloud of GPUs. When you start talking about SmartNICs and NVMe and these other types of differentiated hardware, I think that there's going to be tons and tons of work to do and innovation to deliver still.
Yeah, I think so. That's a good answer, and I would pass it on to. Vipin.
Hi. I have one quick question. So recently, I'm looking at virtual machine image tagging. So do you have any reference that on this to have image taggings for virtual machine, just like we have in OCI container images in the community? So for OpenStack images, are we expecting some kind of virtual machine image tagging?
Virtual machine image tagging, is that the question?
So in containers, we have tags for our containers images, right? To kind of version control them. So can we have we seen any such similar work for virtual machine in the community for OpenStack?
Yeah, I mean, so within OpenStack and the Glance service, the Glance service has a metadata service that you can add tags to, and you can use those tags for scheduling and versioning and those kinds of things, I believe.
Okay. Although we have a lot more questions, but I think we are running out of time as well. And on behalf of the organizing team, Open Technology Foundation, Frost and Teaching Learning Center, Ramanujan College, University of Delhi, we extend our heartfelt thanks to you, Jonathan, for taking out time and interacting with our participants. We really hope to have more engagements with you in the near future. And thank you so much, Jonathan. Thank you so much.
Yeah, thank you.